Today you're going to learn everything you need to know about Pandas. This is the library that you have to master if you want to be a data analyst or a data scientist, so get ready to jump into the world of data analysis. If you want to make the most out of this video, I highly recommend you to code along with me, pause the video, stay engaged, play around with the code and see for yourself just how amazing Pandas can be. For the first 30 minutes, we're going to focus on helping you think Pandas, okay? And after that, you're going to have a rock solid foundation to integrate the syntax I teach with a very practical hands-on approach using real-world datasets to make it more enjoyable and also easier to digest the content. Då ska vi köra igång. Alright, so for this code along we are going to use Jupyter Notebook, and if you do not have the Anaconda distribution, you simply type Anaconda download in your Google query window, press the first link here and then press download. Follow all the steps, agree to everything and you shall be fine. Alright, so if you have Anaconda or if you have downloaded Anaconda, we can open it up using the terminal. If you are on a Mac. If you're on a PC, you can open Anaconda prompt instead. So here you simply type Jupyter Notebook with a blank space in between and then enter, and it is going to open up your Jupyter Notebook. Then what I like to do here is to use this dark reader thing to make it all dark mode. I think it looks nicer, and then I simply go here, create a new folder. I'm going to call it Ultimate Pandas Tutorial 2023 because that is what we're doing. Alright, I'm gonna go inside of here, gonna press new, and I'm gonna say Python 3. This is going to open up a new Python notebook. I will also name this by pressing here, naming it Pandas Tutorial. I'm also going to zoom in here a little bit so that you can see the code better. Alright, starting off, I'm going to press Escape M, then Enter, which is going to turn the cell here into Markdown. And then I can write some nice headlines. Ultimate Pandas Tutorial 2023. Alright, now let's start by importing the libraries that we will need. So the first thing that we will need is the Pandas library, obviously. We're also going to use some other libraries like NumPy and the matplotlib.pyplot as plt. We're also going to use Seaborn a little bit, and that's about it. Okay, so I'm importing matplotlib and Seaborn because throughout this code along I am going to sprinkle some data visualizations. Alright, okay, let's get started. The first topic, I'm gonna do Escape M, Enter here again to turn it into Markdown. Then the first topic is going to be DataFrames versus series. Alright. This is the first topic. So we're going to get the data frame here. So you're only required to use this link. I'll put it in the description below. So you can just copy paste this and then run it to get the data frame. So if I just simply type df now, I can see this data frame. So we have a large data frame consisting out of 16,000 rows, and each row is a video game basically. So we have a video game, the name of the video game, what platform it was released on, what year it was released, type of video game, the genre, who published the game. And then we have sales here, so North America, Europe sales, Japanese sales and other sales. So here we have global sales, which is just the sum of all these four sales combined. So we have data frames in Pandas, and if I say type of df, we can see this is a data frame. This is the most important object in Pandas. And then we also have the other object, which is a series. A series is a column from a data frame, or doesn't even have to be from a data frame. So if I copy and paste it here, and then do type, you can see it's a series. So we have these two objects, data frame and the series, and those are the two objects in Pandas that we're concerned with. And why does it make sense to talk about objects when we're doing programming? Well, if you think about it, we make sense of our physical world through objects. So if you would look around in your room right now, you'll discover that you're surrounded by objects. Simply put, we navigate reality through understanding of different objects, be it physical or abstract objects. And since we do this in the physical world, I guess some smart programmer figured out we're also going to model our virtual reality according to objects. So that's why we have object-oriented programming. So just think of the data frame and the series as two things that we can transform and change. Moving on to next topic, inspecting data in Pandas. So one of the benefits with Pandas, and partly why it is so popular, is because you can very quickly get a great overview of the data you have. So for example, how we would normally start off inspecting a new data set right after reading it would be to do, say, df.head to get just an overview of the top 5 rows. Then we would go ahead and say df.info. Here we get a nice summary output of the data. We can see if we have any missing values. We don't have that here because I've cleaned this data set for you already. 10 columns. We have a range index, which means that it goes from 0 to n. Then we have the name of the columns, what data type we have here. So we have object, integer, and floating point. So object type is the same as string data type. It's just in Pandas we call it object instead. We can also see the memory usage here, number of columns that have a specific data type. Third, we would do this. We would say df.describe. So describe is going to get us some summary statistics of the numerical columns in our data set, so the integer and the floating point. So oldest game is from 1980. You can see that the newest one is from 3 years ago, and 50% of the games we have in this data set were made before 2007 and 50% were made after that. Then we have the sales here, so we can see that a lot of the games didn't sell for that much. We can see that only a few percent of the games make up for a majority of the sales. What we can do with this describe method as well is that we can say df.describe and then pass include equals to O, or object. If I do that, I'm going to get summary statistics on the object columns. So we get slightly different output here. So we get the count, which we also get in the previous one. Then we get number of unique values in that column. So we have some games that actually are the same here. So same game for different platforms. And the most frequent value here, so would be Need for Speed. On the platform, we can see that the most are Nintendo DS games. Electronic Arts is the most frequent publisher. And then action games seems to be very popular. And we also see the frequency here of the top value. So 12 Need for Speed Most Wanted. Alright, so by looking at these 4 methods, we can quite quickly get a good understanding of what data we have at hand. Good. Moving on to next topic. Selecting columns in Pandas. In Pandas. And I'm pressing escape M and then enter to get this markdown cell, which I think looks very nice. First, we have columns here. So this is df.columns is an attribute which gives us a list of all the columns that we have. So if I were to select a column, say the genre column, I would say df, then brackets, and then pass the name of the column as a string. So df genre. There are actually two types of syntaxes to do this, to select a column. This is the fancy and sophisticated way to select a column. And there is also another one, which, and I call this bracket notation. So maybe I'll just type a comment here saying sophisticated way of selecting a column. Bracket notation. All right, then we have the lazy way to select a column. Lazy way of selecting, which is called the dot notation. Okay, so to select the genre column here, I would simply type this. So this gives me the same output. This is better because it's easier to write, it's faster, you don't have to bother with the brackets and the quotations. However, this way looks nicer, it's more readable, and it always works. So this syntax always works. This doesn't always work. Let me show you an example of when it doesn't work. df.global sales. Here we have a white space in between in the column name. So since I have a white space, I can't use this syntax. If I want to select the global sales column, I would have to type it with the bracket notation. Voila. Now it works. All right, selecting several columns. How do we do that? So to select several columns, we can't use the dot notation either. We're going to have to do with a bracket notation. So when we're selecting several columns, we're going to pass a list of strings, right? So it's different from selecting one column when you only pass a string. So here I can select name, oops, should do it in quotations like this, and then year, I can do global sales. If I run that, I'm selecting these three columns. All right, other ways to select columns, we have some nice methods for that. We could say df._get_numeric data, and I enter here. So now I'll get all the numerical data in my data frame. We also have another method which can be quite useful, which is called select dtypes. Here we can say object, so we can be more precise here. We can select object columns only. We could select only floating point. We could select only integer. We could also say number to get both integer and floating points. We could, if we wanted to, maybe have only, we could pass a list here, say object and, object, comma, integer, to get object and integer. So this way of selecting data types is quite straightforward. And another thing that I would like to show you is that since when we're selecting several columns, we have to pass a list, that also means that we can select columns based on different conditions. So if you've done some Python before, most probably know what a list comprehension is. So if you understand list comprehensions, I'm not going to go into it here. We can actually create conditions here by looping over the columns. So we'll say column for column in df.columns, and then we can create a condition here saying if df of col dot nunique is greater than 50. So here I'm basically looping through each column and checking if the number of unique elements in that column is, less than 50. Less than 50. So this is just an arbitrarily chosen way of selecting columns, but I just wanted to show you that we can actually filter using list comprehensions, and that can be quite useful if we're working with a large data set that consists of maybe 100 columns or something like that. Moving on to the next part here. So now we're going to talk about methods versus attributes. So this is really important topic that I wish you to understand. Remember that we're dealing with two objects here in Pandas, which is data frames and series. And objects, they have attributes and methods. So to understand what this means, we can draw analogies with physical objects. So let's consider a lamp. A physical object will always have an attribute or a state. So the state of a lamp can be turned off. If I apply the method of pressing the switch, I will change the state of the lamp to turned on. It's the same thing goes for objects in Pandas. The data frame object can be in a certain state. For example, it can have 16,000 rows and 10 columns. And to change the state of this particular data frame, I can apply a method to alter its state. If I apply the method of dropping a column, so df, you can see here, this is the current state. So if this, okay, let's just do df.shape. This is an attribute and it gives me information about the current state of the data frame. If I say df.drop columns equal to name, we can see here that the state of the data frame has been changed because I've dropped one column. So I apply the method of dropping a column, getting rid of one column, and that is going to alter the data frame. So now if I do the shape on top of here, we can say that the data frame has a different shape. It has a different attribute. So the difference between a method and the attribute is that the attribute is going to provide you with information about the current state of the object. In this case, the object is a data frame, and the method is going to change the state of the data frame. So for example, here I have the data frame. It has 16,000 rows and 10 columns. If I apply the describe method here, I'm going to change it. So now it has way fewer columns and way fewer rows and way fewer columns. I think this makes sense. So for example, if I select the column here, like year, then I can say value counts like this, and then I'm going to count the frequency of games. So we have 1,400 games that were made in 2009 and also 1,400 in 2008. And since this is a method, I can change the state in different ways by passing different arguments to the method. So I could, for example, say normalize, which is by default set to false like this. But if I set it to true, I'm going to alter the state of the series here in a different way. So instead of getting the absolute frequency of games, I'm going to get the relative frequency. So instead of saying 1,400, it's now saying 9%. Now, when we understand what methods are and what attributes are and what makes them different from one another, we're going to start building some intuition or common sense in Pandas. Intuition or common sense in Pandas. So some methods and attributes in Pandas can be applied to both the data frame object and the series object, and some can only be applied to one of them. And when you're a beginner in Pandas, it can be quite difficult to know which methods works for data frames and vice versa. But if you really think about it, you can develop an intuition or common sense for figuring out which methods work for data frames and which methods works for series. So allow me to create a variable here saying df year. So now I have year here, which is a series, right? It's a series. Then I have my DataFrame. Okay. So if I say df.shape, I can get information about the shape of my data frame. Do you think it will work on a series? Does a series have a shape? Yes, it does. Series also has a shape, but the shape is different. So a series is always going to provide you with, okay, how many rows do we have? It doesn't provide you with any columns, because a series is one-dimensional, whilst the data frame is two-dimensional. So one-dimensional and two-dimensional means basically that 2 dimensions are rows and columns. So by getting an individual value from a data frame, we can get it by specifying the row number and the column. When we're working with a series, on the other hand, we only need to specify the row to get the value. Okay, moving on. df.columns, which is an attribute that works on the data frame. Does this work on the series, do you think? No, it does not. It says attribute error. Series object has no attribute columns, right? So if we think about it, this kind of makes sense, because a series is only one column. And here it says columns in plural. Oh, I don't know how to say that word in English. Several columns. Alright, so this doesn't work. If I say platform, select that column. So I have a series, and then I say value counts. If I run that, I'm counting all the individual values and ranking them from top to bottom. So we can see here, DS games are the most frequent ones, followed by PlayStation 2 and PlayStation 3 games, and then we have the Wii games. Alright, so basically getting a frequency count for a series. Can I do this for the whole data frame? It does not give me an error, but looking at the output here, what's going on? Well, it looks absolutely horrible. So we're not getting an error here, but the information that we get doesn't make any sense whatsoever. So the short answer here is no, you can't apply value counts on the whole data frame. And the reason for that is that all the columns needs to be of equal length. And since we have different number of values in the columns here, we're going to get different lengths of each series. So if we want to use value counts, we can only use it on a series. Alright, one more example. So let's do year and then have a look at sort values. Okay, so I can sort the values in my series. Can I do this on a data frame? df.sort values. Okay, no. It seems at first glance that I can't, but if I read the error message here, it says sort values missing one required positional argument by. So when I'm applying this method on a data frame, I have to pass by, and here I have to specify by which column I want to sort this data frame. Boom. So now I'm sorting it by genre, for example. So we can see that we have all the action games here stacking up on top, and then in the bottom we have strategy games. Now we've developed an intuition for Pandas. So now we're going to talk about another very important concept to become fluent in Pandas, which is method chaining. So method chaining in Pandas. So this is going to be a short section. It's a big thing, and it allows us to put methods on top of each other. And the methods will be executed in chronological order, meaning you have to be aware of how each method will transform your data. Okay, so let me try to explain what I mean by that. So if I say df genre, okay, and then I say value counts, like this. Okay, I'm applying a method now, which means that I'm changing the state of my series. It looks different. Now I want to apply a new method. So I'm applying this method on the new method I'm applying it on the already altered series. So I want to sort index. So now if I run this, the index is going to be sorted alphabetically. If I were to say, for example, in a different order now, df sort index, okay, it sorts the index, but in the genre here, so now it's just the index was already sorted, and then if I apply value counts like this, the index here is not sorted like it's sorted here, right? Because I'm sorting the index on the genre column here, and then I'm doing value counts, so I get a different output. So we always have to be aware of how we're changing the state of the series or data frame by applying every method. Back to the first example here. I select the genre column, applying value counts, then I'm sorting the index here, so it's alphabetical. Now I can apply plot.bar, for example. So now I'm plotting this. If I do type of this, we can see that it's not a series anymore. It has been turned into a plot. So at each stage here, at each step, I'm transforming my data. And this is really important concept to understand and to make use of if you want to get very proficient in Pandas and use it in a professional environment. Now we're kind of done with the first part of the Codealong, which was a lot about understanding how to think in Pandas. And now we're gonna get down to some of the very, very important and fun syntax stuff. First stop is the most, it's very, very important at least. So it's the locate and integer locate. So this is how we are going to filter and navigate parts of a data frame, and it's imperative Pandas to understand this. If we understand this, we can filter values in creative ways, and we can get really good at playing around with data in Pandas. Okay, so starting off, we're gonna do integer location. So if I do iloc 4, for example, I'm going to get a series, but it's going to be the 5th row, right? As a series. So if I say df iloc 1, I am getting this row. Good. So if you know some Python from before, you might have seen this, because this is how we would slice a list. And it's the same syntax here, and I don't even have to specify 0 here. It's going to give me the same output. So, but just to show you df.iloc here, so I'm going to select the first column. I'm going to go to index position 10, but not up to 10, not including it, right? So here I get from 1 up to 10, but I'm not including 10. So I like to call this syntax start, stop, and then step. So this is the syntax, start, stop, step. So on the left-hand side of the column, we have the starting position. We want to start on 1. Then we want to go up to 10, but not including 10. Then we can add another column and select the number of steps. The default setting here is 1, so it goes with a step of 1, right? 1, 2, 3, 4, 5, and so on. If I change this to 2, I'm going to get every other value here. So I'm getting 1, 3, 5, step of 2, right? And I can have step of 3 or whatever I feel like. Another thing which we might be interested in knowing is that we can select negative rows as well. So I want to go to this means the last row. From the first index position to the last, but do not include the last one, right? If I want to go to the last one and include it, I simply type this. but I can do. And if I would want the last 10 rows, I would say -10 here in the start. Alright, so data frames, they are two-dimensional, which means that we now, and we've only been working with rows up until this point. I can work with the columns as well. So we're just gonna continue to build on this syntax a little bit. So this means select all rows, but I only want to select column 2 to 5. So from start to end, right? So the syntax here is basically start, stop, step, and then we need a colon. Maybe I should do it like this. A comma is what we need, not a colon. And then we say start, stop, step for the columns. So this is for rows, and this is for columns, right? So here this is integer column 0, 1, 2. And then I'm saying 3, 4, 5, but do not include 5. So I'm just getting these values, as we can see here. Year, genre, and publisher. And I can, of course, also here use the minus syntax if I would want that as well. Okay, so this is integer location. So integer location, it's called integer location because I have to specify everything here with integers. Sometimes, or actually oftentimes, we want to specify the location based on the column name, for example. So if we want to do that, we would use the loc syntax. The loc syntax works almost the same as iloc, but if I say go from 0 to 5, it's actually going to include the fifth element. So it's going to go 0, 1, 2, 3, 4, 5, and also include it. It's going to go up to 5 and include it, which is different from iloc, right? So if I do I here before, I get one column less. So I do not know why they have that, why they're different there, but they are, so it's good to know. All right, say I want to select the first 1,000 rows of this dataset, then I want to select a column. Now, if I'm using locate, I have to type out the name of that column. So let's select publisher column. Publisher. Boom. That is pretty straightforward. What I could do as well is that I could say dfloc select the first 100 rows, and I can select several columns here. But if I want to select several columns, I'm gonna have to pass a list, right? So I select platform, I select publisher, and maybe NA sales. Oops. Okay. So straightforward, right? Very straightforward. So these are the basics of the iloc and loc syntax. One more important thing also is that we use the df.locate syntax, for example, if I want to update a certain value in the data frame. So df of maybe row number 100, then I select one column called NA sales, oops, like this. So this value, let's say I did some research on this value and I found out that it's not correct. I have to change it. I have to update this particular value, and now I want to update it to 3.84. Was a little bit wrong. Boom. So if I look at this value now, we can see that it has been changed. So this is how you would change or update a value in a data frame. All right, now we're going to continue with the loc statement here, but we're going to do it with, we're going to introduce conditional filtering as well, conditional logic to filter data. So filter with conditional logic using the locate method. All right. One thing that can be nice also to do when we're gonna do this is to, if you want to get an overview of the data, it can be nice to look at some of the object columns. So we could say like these columns, I can say that I want to loop over them and then have a look at all the unique values inside of that column. So this can give you a pretty nice overview of the unique values that we have in our data frame. Okay, so how do we use conditional logic to filter our rows in the lock statement? We would do something like this. So now I'm going to select the column platform and I'm saying double equals to we. If I run that, I have this we series now with Boolean values, so true or false. And if this evaluates to true, it means that in the platform column, the value is equal to this string exactly. If it says false, it's some other console or platform. Now what I could do, value counts here, see, okay, 1290 games are from the Wii platform, and I could also say df.locate Wii. So now I'm getting the whole data frame of Wii games. So we can see here in the platform, everything is equal to Wii. So this little true or false series put here in the lock statement is going to allow us to filter. So it's going to include every row that has Wii equal to platform. All right, so that's the basic idea of filtering using conditional logic. And I could, of course, also just type out the logic straight into the brackets here, like this. Right? However, when we're doing more complex conditions, writing more complex conditions, I think it could be a nice idea to just turn this into variables, because it's going to make your code more readable. But it's completely up to you, of course. All right, so let's try a different filter. So let's say I want to get the names of video games that had a higher sale in Japan than they had in Europe. In the Europe. So I'm selecting here, Japanese sales is greater than in the Europe sales. So if I select it like this, I'm going to get all the columns here. But if I only want the name, I will type it here with a comma. So now I have a list of games that had higher sales in Japan than they had in the EU. So we can see we have a lot of Pokemon games that sold more than in the EU. Okay, so if you want several different conditions to filter on, we're going to need to place them inside of a parenthesis. So now I want to get all the role-playing games for Nintendo Wii. So I would type df.locate, and then now parenthesis here, df platform double equals to Wii, and then we have the and here, so parenthesis df genre double equals role, this role playing, no, like this, boom. Okay, so the and operator here requires that this evaluates to true and that this evaluates to true. So both statements need to evaluate to true. Alright, so then maybe I want to also see here I could do sort values on this data frame here, and then say I want to sort values by the global sales, and then I want to sort it ascending equals false, so descendingly. So now we can see that the most sold role-playing games on Wii was the Monster Hunter Try, and then we have Pokemon Battle Revolution and some other stuff, Dragon Quest. Alright, and here we can see that they're sorted here descendingly on global sales. So however, if I'm this is also one pro then of not having to deal with one idea. If you don't want to deal with the parentheses here, then you can just create the series like this. So then we can just create a series and then say like this, okay, role playing, boom. And now what I could do, I'm going to get the exact same output here. So I'm going to say we and RPG, boom. Now I don't need to use the parentheses. And I think it's kind of nice to create these variables, especially if you give them names that make sense. So here it's kind of intuitive to understand, okay, we want to look at games that are Wii games and that are RPG games. So it makes a lot of sense for readability to do it like this, I think. All right, let's have a look at the OR condition. Filter with OR. At least one. Okay, so the OR condition is slightly different from the AND condition, because in the OR condition we only need one condition to be true for the whole expression. If both of them are true, it's also going to evaluate to true. And if all of them are false, the whole expression is going to be false. So here I say I want double equals action So here I am saying I want action games or shooter games. That's what I'm going to type now. I want action or, and to do that I'm going to use this pipe character. So or shooter. So as we can see here in the output, it's either shooter or action games, right? So as long as it's action or shooter, it will be included in my output. All right, now we are gonna try to filter with both or and condition. All right. Okay, so now I'm gonna write a new condition here saying it's gonna be since 2010, and I'm gonna say df year greater than or equal to 2010. df.locate, and now I'm gonna say since 2010 underscore and parenthesis action or shooter. Okay, so for all the attentive people, you might have noticed that I put parentheses here and parentheses here. Why did I do that? Well, if I were to remove the parentheses here and the parentheses here, it also works. However, I get a different number of rows here. I get more rows, roughly 900 more rows here. And why is that? You could think about that for a little bit, and then I'll explain. Okay, so the idea here is that if I remove the parentheses here, this expression is going to be evaluated together. So here I'm saying since 2010 and action games. This means that I'm going to get all action games since 2010. Or I will get every shooter game, regardless of when it was released. So we can see here on the first row I get the Duck Hunt from 1984, which had great sales. Duck Hunt. I have to Duck Hunt. Sounds kind of fun. Oh, okay. And here we're saying since 2010 for all the games, action or shooter games. So it can be either action or shooter games, but they all have to be released since 2010. Right? So the parenthesis is really important for the order of operations. Right? So order of operations is a little bit the same as it would be in math. So we start with the parenthesis, right? Evaluating this, boom, action or shooter games, and then we're evaluating these two together. That's very important to have in mind, so you don't get the wrong outputs. That can be very embarrassing. All right, if I want to filter on several publishers without repeating myself, I can use a method called isin. Isin method, very convenient to use together with the loc method. So I'm going to say top 3 publishers, and then I'm going to say df.publisher.isin, and when I'm using the isin, I am going to have to pass a list. So I want to select Electronic Arts and Activision and this one, Namco Bandai Games. Okay, so if I now say df.locate top 3 publishers. So now I'm selecting all of these 3 game publishers. So why is this nice to use? If you have a list of things that you want to include from a column, it's much nicer to put that list just straight up rather than having to type df.publisher double equals Electronic Arts or df.publishers double equals Activision or blah 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 blah. It gets very tedious and very tiresome quickly. This is much more convenient. Okay, now we want to use some more conditions here. So we're going to select genre.isin, and we're going to select some popular categories here: sports, action games, and shooter games. All right, and then I'm also going to be interested in having a look at all the sales greater than 2 million. So df brackets global sales. Oops, this has to be, no, df global sales greater than or equal to 2 millions. All right, so now I'm going to write a condition to have a look at the genres and top 3 publishers that sold for greater amount, for greater sum than $2 million. df.locate genres and top 3 publishers and sales to M. All right, okay, so another very convenient method to use inside of the loc statement is the between method. So between allows us to specify a range. All right, so if you've done SQL before, it's basically the same thing as the between keyword in SQL. So Now I'm interested in games that sold between 2 million and 10 million. So then I would say df dot, not dot, df global sales dot between, and then I specify the range 2 and 10, and it's inclusive on both ends. So let's try some other examples here. Let's do for different years. So let's do all the 90s games. So we say df year dot between 1990 and 1999. Then just copy paste here, change some stuff in the start of this century. So from 2000 to 2009, and then from 2010 till 2019. So now I can say df.locate between 2 and 10 millions and games created in the 90s. And I want to get the genre. Yeah, I should put an S. Alright, so now I get all the genres of games that sold between 2.2 to 10 millions in the 90s, and maybe I want to do a value count and then say normalize true with an E. Okay, so what does this say? It says that of the games that sold between 2 and 10 millions in the 90s, 20% of those sales came from the platform category. 16% or 17% came from action games, right? And that can be quite interesting. So what were the most popular categories in the 90s for the games that sold in huge amounts? So we could have a look at that for the year of 2000 and for the previous decade here. So then we can compare these perhaps. So we can see that action games has gone from 16% to 25%. And we can also see that, well, strategy games were up here, they've slowly decreased, then they've gone up a little bit. So we can see how different genres has changed in popularity over the years, for example. Alright, now I would also like to show you how to negate a conditional statement. So how to negate it, how to turn it to its opposite end. I would do that with the tilde symbol, this one, right? So if I say df genre and then .isin puzzle strategy and adventure, for example. So now I'm gonna select all the genres that are not these, right? So everything that's not puzzle, strategy, and adventure is what I'm getting here. And if also another point is that if I say and everything in the 10th, underscore here, I am actually, this will not be negated. So this statement is not negated, right? It's just the one here that's being negated. If I want to negate both, I would have to say parenthesis here to negate all of it. Or I would put the tilde symbol in front of this one as well. Whoops, like this. That also works. All right, okay, so now we're gonna close up this section, but before we do that, I'm going to present you with an exercise that I would like you to try out to write a difficult condition. So let's do an exercise to prove to yourself that you've actually understood how to filter a Pandas data frame. So let's find out which racing games had the highest sales in EU compared to North America, Japan, and the other sales column. And this should also be between the years 2000 and 2009. All right, so try to figure this out. I'll give you some time and then I'll explain it to you. All right, so what we need to do here basically is that we first need to read the question here. What data am I getting here? So we're working with racing games. Okay, let's start with that. Break the problem down into smaller parts. So we want the genre to be set to racing. All right, now we said that they should have the highest sales in EU compared to NA, JP, and other sales. So in order to get the game, it should have had higher sales than in the North America, and higher sales than in Japan, and higher sales than in other sales. So how do we write that? Well, we need to be very clear here. So we're gonna have to say DF EU sales, capital U here, and then we're gonna say greater than DF of the Japanese sales. So, and it also needs, I'm gonna copy paste this, to be higher than in the North America sale, and it needs to be higher than in other sales, right? So greater in EU than in Japan, and greater in EU than in North America, and greater in EU than other sales. So I have to write it like this. Then I'll say from the between the years, and I'm going to use the between method. So I'm going to say df of year dot between 2000 and 2009. All right, so these are the three conditions that I need. I can also run this to make sure it works. Okay, good, it works. Now I can say, I'm actually going to do it in the next cell here. So df.locate, so it should be racing and highest EU and the beginning of the century. Now I might only be interested in the name of the game and in the how much the sales were in the European in Europe. Okay, sort by EU sales, and then ascending equals false. Nice. And then I'm actually just going to say head. I want the top 5 rows here when I've sorted it, and I'm going to set index to the name column. So here I'm once again using method chaining here. I'm chaining on methods on top of each other. First I'm using the lock method to filter what the data I want, and also selecting the columns that I want. Then I'm applying sort values, and I'm sorting it by this column in a descending order. Then I'm just selecting the top 5 rows and setting the name column as index, which gives me this output. So, Need for Speed Underground 2, I've played it, it's pretty fun. It's the most sold one here in the EU. It sold more in the EU than it did in North America, Japan, and in the other parts of the world. And then Simpsons Hit and Run, I also played that. Gran Turismo 5, also played that. Not on PSP, Motorstorm, I don't know. Okay, now we are going to have a new section here, which I've named Most Useful Methods for Data analysis. All right, and I want to have boom. Okay, so the thing with Pandas is that it comes with a bunch of methods, and that's why it's such a versatile library. And the idea behind this section is to walk you through the most frequently used methods and the different ways to use these methods. So I'm trying to apply them to different use cases and when they're good to use. And yeah, the leading principle here is like 80-20. So I'm going to show you 20% of the most common ones, which are used in 80% of the cases. All right, starting off with the query method. Query method is an alternative method to the loc and iloc methods. I do not use it that much. It's a different way to filter data in Pandas, and unlike the loc method, the query method takes a string as its Boolean expression. Let me just show you how it works, and then you can make up your mind if you rather use this than the loc statement. So you pass a string here, you say NA sales as a string, greater less than Japanese sales. Oops. Japanese sales. And if I want to make more complex filtering, I can do with conditions. I can do like this. So I say publisher double equals, and if it's supposed to double equal a string here, I'm gonna have to do single quotations or just different quotations than I have here. So Ubisoft and the year. So I'm typing out and here. I'm not doing this, I'm saying and. Year greater than 2014. So everything released after 2014 by Ubisoft. Alright, and then also just maybe I want to have all the PlayStation 3 games. Ta-da! Okay, next methods are the unique and nunique. You've already seen them in this Codealong, but what they do basically is, so if I select a column and say .unique, oh, my spelling is not on top, boom, I get all the unique values from that column. And then I can say df.n unique, and then I get the number of unique values in the whole data frame. So this works on individual columns. The nunique works on data frame and on series. So boom. However, the unique one does not work on a data frame, but you can, as you saw earlier here, you can just loop over the columns and then print unique for each iteration, right? I'll show you quickly how to do that. So you say for I in df.select D types. I'm just going to take the object columns for this loop here, and then I'm going to need to print here. So now I'm just printing all the unique values here. So here are the names, platform, unique genres, and so on. Okay, so that's the unique and nunique. They can be quite nice to use when you start off playing around with the data set to really understand what values do I have in this data set, what are the unique values. The nunique gives you some sort of intuition for what kind of column we have, if it's a continuous variable, a categorical one. The nunique can give you a good intuition for that. Now we're going to have a look at the rename and set index. Alright, so if I select this PS3 variable here that I've created with a data frame slice of only PS3 games, then we can have a look at the index here. So since I've sliced this out, the index is not really a range index here anymore. And that's because from the original data frame, the first PS3 game had the index position of 16. So if I want to work with this data frame and only analyze PS3 games, then maybe I want to reset the index. So reset index. And then I could say, if I just do it like this, boom, if I just reset the index, the previous index is becoming a column, and I get a perfect range index here. If I don't want this column, since it's not going to help me, I can say drop true. So then I will drop the old index. If I look at PS3 here, we can see that nothing has been changed here. And that's because I have to say in place equals true in order for the change to be permanent. And this goes for a lot of functions or methods in Pandas. So if you don't say in place equals true, then the change is not going to be permanent or in place. So I said in place true, you can see it doesn't return anything if I do that. But if I look at PS3 now, we can see that I have managed to reset the index. Then we have rename, reset index, and rename and set index. Okay, so set index, we've seen that too actually, but I'll show you again. So set index, maybe for this use case it could be a good idea to have the names as index, since they are pretty unique now that I only have PS3 games. So if I set this as index here and look at PS3 here again, we can see change is not permanent, which means that if I want it to be permanent, I'll say in place equals true. In place equals true, and the change has been made permanent. Alright, okay, so now to rename. If I want to rename something, if I want to rename the columns, for example, I would say ps3.rename, and then I would pass a dictionary here. So I would pass a dictionary saying EU sales, which is the name of the column I want to change. I put that as the key, and then the value should be, okay, now it should say Europe. And I don't want I want to change the NA sales as well to North America. And if I just run that, doesn't really work. So okay, something is not working, and that is because I have to specify an axis that I want this change to happen on. So if I say axis equals 1, it knows that it should go and change on the column level. So axis 1 is this, axis 0 would be the index. So I'm renaming the columns here. And if I look at PS3, you can see that the change has not been made permanent. So if I want to do that, I'll say in place equals true. In this case, I don't really want to rename the columns. I'm just doing this to show you how the method works, so I'll leave it be. Okay, and now if I want to change a value here on the index level, I'll show you how to do that. We're still going to pass a dictionary, and maybe I want to change this here. I want to change Black Ops 2. I'm just gonna say and now we can see that I've changed the name here, right? But it's not permanent. So actually the default, I'm doing Shift Tab by the way here to see the documentation. So axis is set to none, which means that I don't have to specify it here, but just to be clear here, I can just specify it like that. Boom. All right, next popular method, or there are two popular methods here. So it's the nlargest and nsmallest. All right. These methods are good for getting an understanding of the dataset from scratch. So if I say ps3.nlargest, and then I can specify n here, so the number basically, the largest values, and then I say columns equal to NA sales. Boom, I run this. Now I get the top 10 games sorted by sales in North America. So we can see Grand Theft Auto 5 was the most sold PS3 game in North America. Now I will also attach a lock statement here. Maybe say, okay, select all rows, but only NA sales column, like that. And then I want to plot it in a bar plot. All right. Okay, so I think this is quite a efficient visualization to just have a look. Like if you're starting to look at a data set, you can just have a look at, okay, what products had the highest sales in this part of the world. And we could also do this visualization for each country. So let me do that and introduce you a little bit to the fig.ax syntax that we have in matplotlib. So I can make subplots. So now I'm using matplotlib actually. And I think this is also really good to know. I might create a YouTube video on how to use matplotlib as well. So we're going to say the same thing here. Basically, I'll just take this code here. I'm just going to take it. And then in the bar here, I'm going to say that ax is equal to ax0 bracket 0. Okay, so why am I doing this? I'm setting the subplots 2 times 2. That means I will have 2 rows and 2 columns, so it's going to be 4 plots in total. And this is just setting the size of the whole figure in inches. Okay, and ax equals 0, 0 here is that means that we're going to have it on the first row and the first column. And then I'm going to have to set ax here, 0, 0 again. And then I'm going to say set title, and I'm going to say North America. Okay. Now I'm going to copy paste this. Paste, paste. Okay. Now I'm going to change here and here. I can type in 2 places simultaneously if I place my cursor and then press down Command if you're on a Mac, or Control if you're on a PC. So pressing down here and then here allows me to write on 2 places simultaneously. So I'll do that here as well. So here I want to change this value and this value to 1. Boom. And here it should say Japan. Marking this place and saying EU. This should be 1 and this should be 1, and then I'm changing this to Europe. And now I'm gonna do, here is other sales, marking it down with Command, other sales, and here I'll have to say 1 and 1, so that's going to be the last one. And also here, other. And then in the end here I can also say fig dot supertitle or subtitle most sold PS3 games by continent. And then I can also set the font size here. And then I'm going to say figure.tight layout. And then I have a figure here. which is pretty nice. So I can quite easily, if I get really good with Pandas and also then with matplotlib, get nice looking visualizations in an instant basically. And I have this ability to customize them. Alright, and then if I want to save this fig here, I can do that. So I have this figure object. Now, this is the figure. If I say fig.savefig and then say what the name I want to save it as, so ps3 sales, and then I can save it as any image type I want, so I can save it as a TIFF, like that. And then if I go back here, we can see that I have a file here, and I cannot open it in Jupyter here. If I do ps3 here, I get it like this. So now I can just take this and put it inside of a presentation. Another thing that's actually nice to do, which I forgot to do, is that you can say transparent equals true. So if you run that, since I have the same name here, I'm going to overwrite the previous file. And if I try to open it here again, we can see now it actually has a transparent background. So if you're doing a PowerPoint presentation or something like that, and you have a theme there, you might want to have a transparent background so it fits in with your background. That's kind of convenient. Alright, so that was the sidetrack. Let's head back to our analysis and to Pandas. So this was nlargest. We also have the reversed option here, which is nsmallest. So it works in the same way. Nsmallest, n is equal to 5. Then we're going to say columns is equal to global sales. And then we have these 5 games had the worst sales performance. Alright, now we're going to have a look at value counts. You are most probably quite comfortable with value counts by now because it's been in this Codealong already. But there are some things we can have a look at here that I think might be interesting. Just to remind you, or to make this interesting, I might copy paste this and say top 100 ps3 nlargest, then top 100 global sales, top 100 global sales for ps3 games. Let's do a value counts on the genre here. So value counts is going to count the number of unique values in this data frame. So the top 100 PS3 games, 30 of them are action games, 20 of them are shooter games. So 50% is either action or shooter games. Then we have sports and racing games that are popular. Alright, okay, so the value counts method. The interesting things we can do here are that we can say normalize true. So instead of getting the absolute frequency, we get the relative frequency. So instead of 30, we get 30%, 20%, 19%, right? We can also say sorted ascending equals false, for example. That's the same. If I set it to true, I get it in the descending order. No, sorry, false is standard. And then that's the default. And then ascending true is the ascendingly, so going up. Value counts is very useful also to get overview of your data and make simple analysis. They can be nice to turn into bar plots like this. Also, if I say bar h here, I have a horizontal bar plot instead. Let's say I want to make another little subplot here with the same syntax. I'm saying fig ax and then plt.subplots. I'm just going to do 1 row and 2 columns. And the fig size I'm setting is equal to a tuple of 16 and 8. And then I'm going to just take this, boom, take these two, and I am gonna say here, I'm gonna say publisher instead. So publisher, and here I'll have to say x is equal to x of brackets 0 and 1. And the reason why I only have axis and one bracket here is because I'm working with one dimension here. So it's only 2 columns, right? So it's column 0 and column 1. In the previous example, when I did figax syntax, I had rows and columns, right? So if I just run that, I have this not all nice looking output. If I say plt tight layout, it should work. Well, yeah, it does work. Looks a little bit ugly. I would need to customize this more, perhaps, to make it look prettier. However, it's good enough for now. So moving on to sort values. Sort values is quite a rich function. We've had a look at it, but not in depth really. So sort values, here I can say ps3. So I have this one, right? And I want to sort the values based on the genre column. So then I say specify genre, sorting by genre, and I can say if I want it ascending equals false, for example. So then I get it in reversed alphabetical order if I do it on a string, and then if I do ascending, it's going to be alphabet. So if I can do it for year as well, if I do year ascending false, I get the newest games first and the oldest games comes last. So then what we can do as well is that we can sort on multiple columns. How would we do that? Well, so we say ps3.sort values, and then we specify by, and then we have to pass a list and say, okay, I want to sort by here, and then on global sale. So if I just do it like this, we can see that it's going to start sorting on year. So it's going to get all the 2006 games, and then all of the 2006 games are going to be sorted on global sales from low to high. So both of these are ascending. So it starts on the lowest and goes to the highest. Then we do the same thing for 2007, get them all in order, and then we sort all the 2007 games on global sales. However, what if I want to sort them in a different way? So I could sort ascending false here. So now I'm sorting both year and global sales ascendingly. What if I want to sort the year column ascendingly, but the global sales descendingly, which would make sense? Maybe we want to look at the global sales, like normally when we look at sales, we want to look at the highest sales. That's the most important thing, the most interesting things to have a look at. So we can actually do that by passing a list here to the ascending one. So I want to sort the year column ascendingly, so ascending true, but the global sales should be sorted descendingly. So I specify false here. So now we can see, okay, for the 2006 games, the most sold games were Resistance, Motorstorm, and Fight Night Round 3, and then Call of Duty 3 here. And then for 2016, well, here we also see only the last ones, but you understand the point here. All right, now we're going to have a look at all the aggregation functions, right? All right, so we have a bunch of aggregation functions that are going to aggregate values in different ways. They are going to be very important to understand when we move on to a very important topic, which is going to be GroupBy, which is coming up soon. But we need to know what the aggregation functions do before that. And then we also have ag, which is a very rich aggregation function, and also the cumulative sum. All right, so for the aggregation functions, I'm just going to print them out here so we can discuss them later. Okay, so what the oh, I forgot. Okay, good. Here we have the aggregation functions that we use the most. So aggregation function is going to make use of every value. It's going to look through every value at least of a certain column and then return something. So we have the min and the max. It's going to look through every value column and then select the minimum value, and max is going to select the maximum value. Then we have the mean, which is the average, basically summing up all the values and dividing it by the number of values in that column. Median is basically sorting all the values and taking the middle one or the two middle ones divided by 2 depending on the length of the series. Then we have the standard deviation, and we can also count the number of rows in a column, and we can also sum up all the values. So we can take all the values and sum them up, and we can also get the mode, which is the most frequent value of a column. So mode of name, and the reason why I did 0 here is because this actually returns a 0 and I only wanted this. So all right, moving on, we have other aggregation methods. We can have a look at global sales, and I'm gonna have a look at the quantile. So quantile of the 80th quantile, 0.61. So this means that 80% of the games sold for less than this value, and 20% of the games sold for more than this value. All right, and I can change this to the 99th quantile if I want to. So 1% of the games sold for more than this, while 99% sold for less than this. Then we're going to have a look at the ag method. So the ag method is pretty straightforward. It works like this. So we can select EU sales, for example, sales like this, and then I say ag, and I can pass a list here. In this list I'll put strings of aggregation functions. Right? Boom. So what I'm getting here is the min value for EU sale, the max value, mean, median, standard deviation, and so on. So it's basically the same like doing this, but I can just pass it into a list. So it's a little bit more convenient. Then we have the cumulative sum. Cumulative sum, just it works like this. So dot cumulative sum like this. So You can apply it to a series like this. However, cumulative sums or running totals are used to display the total sum of data as it grows with time. It does not really make sense to do cumulative sum on this series since it's not ordered in time, right? So in order to do a proper use case of this, I would have to do this first. So we could do the cumulative sum of Xbox sales. Then I would have to say, okay, platform double equals xb for Xbox, and I am interested in NA sales and the year. Okay, and this also needs to be in brackets. Boom. Now I want to do a GroupBy. I'm going to walk you through GroupBy soon enough, so don't analyze this now, just do what I'm doing so we can focus on just showing what the cumulative sum looks like. And then GroupBy, and then I'm going to do sum here. Okay. I forgot this. Now it works. So we have the sales per year for Xbox right now, and I can say Xbox sales dot cumulative sum here. So now I'm displaying the total sum of data as it grows with time. So first year we sold for this, 2001 we sold for this and this, right? This plus this plus this is equal to this. And that's how it works. And normally also when we plot cumulative sums, we want to do it with an area chart. So plot.area. Boom. So we can see it goes up. We have a pretty steady growth of sales here, but then it plateaus here somewhere around the time of the Xbox 360 release, perhaps. All right, okay, so the next topic here is the methods cut and qcut. Okay, so when we are dealing with continuous numerical data, it might be helpful to take this data and put it into buckets for further analysis. So there are several different terms for this. We can call it binning, bucketing, discrete binning, discretization, quantization, and so on. Pandas allows us to do this binning using these functions. So we're going to start with the cut method. So cut is going to allow us to cut the data into equal bin sizes. So what I'm going to do here is that I'm going to select, I'm going to say pd.cut, and x is going to be equal to df of year. So I'm going to take this column and I'm going to say I want 5 bins. So now I've binned this category so I have five intervals here. And if I would do a value counts here, we can see that the range between the bins are the same. Okay, so the bin sizes are the same. Okay. All right. Okay, so what we could do as well is that we don't necessarily have to put 5 here. So what we could do instead is that we could pass a list. So we could pass a list saying 1980. So we know the oldest games are from 1980, and then we can divide it into 1989 to 1999 to 2009 and 2019. So now I'm sort of customizing the bins here. So I'm specifying the range myself. If I do .value counts here, you can see the unique values here and the frequency. If I want to give different names here, I can pass a list to labels here. So I can say labels, and then I can specify like 80s and 90s 00. I did a dot there by mistake. It should be a comma. Here I need to put tens. If I run it, I get different values here. which can be kind of nice to do. Alright, so this is really nice for analysis. So I can actually take this series like that here and then say, okay, I want to create a new column that I'm going to call decade is equal to this. And then actually I'm also going to write here include lowest. Okay, so if I look at the data frame now, you can see I've created a new column here of strings. All right, so that is the cut method. Now we're going to move on to the other one called qcut. So qcut stands for, the Q stands for quantile, so quantile cut. It tries to divide up the underlying data into equal sized bins. So that means if I were to say pd.qcut x is equal to df year, and then I say q is equal to 4. If I run that, it tries to make these numbers as equal as possible. So if I would change this to global sales instead, they're gonna try to make, I might be getting better values here actually if I say precision. Yeah, that looks better. So what the qcut is trying to do here is to have the bins being of equal size, the same number of elements inside of each bin. And precision is about defining how many decimal points to use for calculating the bin precision. What I could do here as well, so I do not have to say q is equal to an integer. What I could do instead is to pass a list, and here I would pass the quantile. So it has to start from 0 and end on 1. So 0 to 0.5 to 0.75 to 0.95 and then 1. So here is one range. In this range I'm going to have 50% of the games. In this range I'm going to have 25% of the games. In this range I'm going to have only 20% of the games, and in the last range I'm going to have the top 5% most sold games. And if I run this, this is what I get. I can also do labels here and then say low tier, above average games, and then we can have popular games, and then mega hits. Alright, so this is the qcut method. If I remove, or I can keep it like this, I'm going to create a new column here, and I will name it popularity of the games is equal to this. Boom. Looking at the data frame, you can see I have popularity of the games here as well. Alright, good stuff. Moving on here, we're going to talk about the apply method, which allows you to apply a function to every value in a column. You can apply it across the rows, or you can apply it across the columns, so across different axes. Normally we apply it across the rows. And you can apply any type of function here. It can be a user-defined function, a lambda function, or a function that you import from another library. So I'm going to give you a use case here on how to use the apply method. I'm going to do some typing now, and I suggest you to type after me. So it's going to take a little bit of time, but just see it as a meditative practice or something. Alright, so I've created a bunch of lists here where I am taking the unique values from the platform category and categorizing them into the company that built those platforms. So I have Sony for the PlayStation ones, I have Nintendo, Microsoft, PC games gets its own category, Atari, Panasonic, Sega. Then we have some other games which I'm just going to categorize as others. But okay, so let me create a user-defined function here called categories. It takes x as input, and then I'm just going to create some if statements here. So if x in Sony, return Sony, and elif x in Nintendo. I can also autocomplete the what I'm typing here, so say Nintendo. Alright, so here if I say elif x in mic, so then if I say mic, I can press tab to autocomplete that variable. Then I'll say return Microsoft, return elif x in PC, return PC, and then we want to say elif x in Sega, return Sega, and then finally if it's not neither of these, I just want to return other. Okay, so I have a user-defined function now which takes one input argument, the x. So now if I want to use this, I can select the platform column, which looks like this, and then I can apply the categories user-defined function that I've created to every individual row here. So to do that, I'll simply type the name of the function here. So the function passing to the apply method should always take one input argument, but when we put it into the apply method, we don't place any parentheses, do something like this. We just type out the name of the function and then we run it. So now I have transformed this column. I've applied this function to every element of the column. So if I do value counts here, we can see that Sony, Nintendo have the most games in this data set. I can also take, I can take this column and add it to platform company. So now I'm just adding a new column here. Boom, so now I have a new column using the apply method. Another way to use the apply method, just so you get the hang of it, is to use another function from another library. Boom. So now I've imported some statistical functions from SciPy. And for example, if I'm working with data, numerical data, for machine learning purposes, I might want to scale it. So one way of scaling data is to calculate the z-score. And I could do that using the apply method. So I would say df.select the types that are floating points. So now I will get all the sales data and I'm going to apply. And I could make a user-defined function here, but in this case it would be easier to just do a lambda function. So I'm going to say lambda x colon, and then I simply say stats dot z-score, which is going to give me the z-score, and then I pass x here to that function. So if I look at the z-score variable now, it has been transformed into z-score, which means that the mean should be around 0 and the standard deviation should be 1. So what the z-score does is that it brings all the variables to the same scale, basically. So here it says 1 point blah 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 something, but it actually, we see here it is a scientific notation. So what this means is that we have 14 zeros before the 1 here. Alright, so they're all very, very close to 0. And you can see here that they're also very close to 1 here. And that means that it's actually worked. Okay, so last function now for this segment. This is going to be the corr method. And corr method gives us a correlation matrix. It works like this. So I can say correlation matrix is equal to df.corr. And I'm going to drop the year column because I don't want to see correlation with the year. And then axis, oops, this should not, sorry. Then I have to say axis equals 1 here, so it knows I'm dropping a column. Actually, I'm going to drop the column first. Year axis equals 1 dot corr. Now what I get is this. How are sales correlating here across different parts of the world? So how do we read this? We read the correlation between North America sale and EU sale. It's a strong positive correlation. And we can see that North America and Japanese has a weaker correlation, but it's still a pretty solid correlation here. And we can also see that North America sales and global sales correlates very, very highly. You can go here, look at Japanese sales. It doesn't correlate that much with other sales and so on. I think that these correlation matrices are really nice to make. However, when I make them, I think it's a good idea to wrap them inside of a heat map. So a heat map is a visualization that comes from the Seaborn library. You can pass corr matrix. So basically it color codes the data so we don't have to sit and read out the correlation as decimal points. It's quite unintuitive to do that. We can say here annotate equals true and not true, and it's going to give us the decimal points here. So it's going to give us the correlation as a number as well. So it's an extra visual aid. Another nice thing that you can do, so if you're an attentive person, you might see here that this part is just a mirroring of this part, right? They're the same values. So you could make the case that, and also the diagonal here is just a 1-to-1 correlation. So there's a perfect correlation between global sales and global sales, right? So we don't need this part really. And we can get rid of that by using a numpy function. So I'm gonna say matrix is equal to np.triu, and then I'm gonna pass the corr matrix here, which is this one, right? Corr matrix. And then I'm gonna create a new heat map, and it's going to be corr matrix. I'm gonna do annotate true, and then there is an argument here called mask, and for the mask I'm going to pass this matrix. If I do that, I only get the part that I want. So when I show correlation matrices, I think that this output is the best because it's only showing the data that's relevant. Alright, now we're gonna move on to my favorite topic. My favorite topic is GroupBy operations. GroupBy operations are the bread and butter of analysis. GroupBy. I'm gonna call it GroupBy. Most important thing. I think that the GroupBy function is the most important one to understand to perform valuable data analysis. So it's used to summarize data across different groups. So I would argue that analysis is about taking a whole and then break it down into smaller components and compare these components with each other. And that is basically what GroupBy allows us to do. So let me just show you how it works, just with the syntax. So I'll say GroupBy genre, and then I'm gonna select the NA sales, and then I'm gonna add sales like this, and then I'm gonna add an aggregate function here. So the average. So this gives me the average sales in North America by the genre. All right, so average sales in North America divided by the genre, right? So this is the average sales for action games in America. This is the average sales for platform games in America. So I'm gonna get a group for each unique value in the column I'm grouping by, right? So if we do df genre.unique, right, I get these values, and these values are going to be the index in the GroupBy operation, provided that I'm passing genre to the GroupBy here, of course. All right, so these are the groups, but to make the analysis interesting, we're also going to need some aggregation. So we need to select another column or several other columns and aggregate them across these groups. So when it comes to the GroupBy here, for example, I could print NA sales, and then I can apply the mean function to that whole column, to every value. But then what I could do as well is that I could select a particular genre with it, like I could say genre double equals shooter games, and I'm gonna select the NA sales column, and then I'm going to get that value here. Boom, this is the column, and then I can apply the mean function to all the shooter games, which gives me 0.44. So the GroupBy function creates this logic for every unique value in the column I'm grouping by. So this value should be the same as shooter here, which it is. So that's what GroupBy does. So I could also create a new data frame, which is called sales by genre. So I'm going to group by genre again, but instead of just selecting the North American sales, I'm going to select all of these sales. So NA sales, EU sales, JP sales, and then I want to look at the mean. So now I get the average sales per genre, but I'm getting it for North America, Europe, Japan, and other. Then I can compare, okay, how are action games different across the different continents? How does the adventure category look different across the continents, and so on. And also, this type of data, I think, is also very suitable to plot it in a heat map. So let's do that again. Here I'm just going to have a little bigger heat map than we had last time. And I'm going to say sns.heatmap. I'm going to pass this sales by genre. I'm going to say I'm not equals true. And then I can also say cmap if you want to change the color. So if I say greens, I'm gonna get it all in green, which is kind of convenient since we're working with money here. So yeah, so we can see that platform games here and shooter games in North America really stands out, and we can see that shooter game and platform games in Europe also stands out. But for Japan, this is really popular, the role-playing games, so RPG games are popular in Japan. Alright, let's continue with the GroupBy function. There is more to know about it. So if I say platform company here, and then I can maybe want to aggregate that across the Japanese sales, and I can use the ag function here. So I can say mean, right? And I'm going to copy paste this. I can also say count. So you can use any aggregation method after the GroupBy statement. And as we know with the aggregation method, we can create several columns here. So we could say, okay, I want to look at sales in Japan. I want to compare the average, and I want to also look at the median, and then I want to count the number of games for each platform company. So what we can see here is that the first thing we can see is that the mean and median is quite different from one another, which makes sense since we're working with sales and money. In normally distributed population, or in a column that's normally distributed, the mean and the median would be the same. So what this means is that the median games, so 50% of the games sold with a value of 0.0, so very, very bad in sales. I'm going to continue to show you some other stuff we can do here with the agg method. So I can pass an extra column here, so I'm going to compare this with global sales, and now I'm going to place a dictionary inside of the agg function. So I'm going to say I want the Japanese sales here, and when it comes to Japanese sales, I want to look at min, max, and the average. And when it comes to, I want to have a look at the mean, and only the mean. Boom. Okay, so then when I do this, I get a multi-index on the column level here. So I get, okay, for Japanese sales, you have the min, max, and the median. And the mean. And for global sales, you only have the mean. Right, so I'm showing you that we can pass a dictionary here to apply different aggregation functions to different columns. We can also go deeper with the group by operations. So we can, for example, group by two categories. So if I want to group by, or make it, I could also call it double group by, I'm going to pass a list to the group by function, and then I am going to say platform, company, and decade. And I want to look at the global sales dot sum. And now I get it in this series format. If I pass a list here instead, it's gonna get me a data frame format instead, if I want that. Okay, so when I'm doing a double group by, I'm first dividing it into the platform company, so I get Microsoft here, and then I get video game sales by the decade. Same for Nintendo, by the decade, other by the decade, PC by the decade, and so on. All right, and of course, if I were to swap places here, if I were to place the decade in front, the decade would become my outer index. So then I would have all the different platform companies by decade. So decade is the outer level here, right? So it's a matter of taste. What is it that you want to show here? So the thing is, when we're doing double group by, gets a little bit difficult to read, in my opinion. So what we want to do, in order to change the format to something that's easier to interpret, is that we can apply and we can stack another function which is called unstack. Unstack is going to take the inner index and turn it into columns, right? So see what it does here. It takes the inner index, which is platform company, and then turns it into columns. So I would argue that this format is much easier to interpret than this. So the default thing that's passed here to the unstack is -1, which means the inner index, right? Calculated from behind, from right to left. I can change this by passing -2 or 0, right? That would be the same thing, right? So now I'm changing, so now decades become columns, and we keep the index as platform company. All right, so I could take this, change this one to 1, and then I could maybe plot it as a line plot to have a look at the sales. And if I do that, we can see that this legend looks a bit ugly because we have a double index here. So it's like global sales, It's not very nice. I'm going to say platform sale per decade. Okay, not the most convenient name for a variable perhaps. However, this is what we get. Oh no, I shouldn't have saved it like this. Without that, now I'm going to say, well, just to show you it looks ugly. Now it looks ugly. We don't want this legend, so we're going to change it. How do we do that? Well, it's not all too difficult. We're just going to say columns looks like this, so it's a list of tuples basically. We can apply a method here called get level values, and then we say we want the inner here, so index 1 of this tuple, right? Oops. Boom. All right, so now I'm just getting the inner level here. Boom. And I'm going to say that platform sales per decade dot columns is equal to this now. So if I look at the columns, they've been changed. And if I take this now, put it here, I have a nicer looking legend. All right, double group bys. Moving on from that concept, the next natural step would be to talk about how to pivot data, okay? Because actually, you might have heard about pivot tables, I assume you have. So how to pivot our data. So basically a double group by with unstack is the same as a pivot table. So I'll show you how to make pivot tables in a jiffy. But first I'm just going to show you some other ways to pivot data. And the most simple way to pivot data is to use the transpose method. So we could take this data frame here and say .t. So .transpose. So transpose is going to turn the columns into rows and the rows into columns. Okay, so that's the most simple way of pivoting data. Now we're going to talk about the pivot table method. So if you have used Excel before, if you have a friend who uses Excel, they might have mentioned pivot tables to you. And pivot tables, if you understand GroupBy, pivot tables are super straightforward. So for the pivot table, we're going to need values, we're going to need to pass a column to index and pass a column to columns, and also selecting an aggregate function. All right, so I'm going to paste that stuff in here. Okay, so here the values are going to be some, normally it's going to be some numerical column. And then for the values here these are the values here. Then we have the index, which is going to be unique values from some column. So let's do popularity. And here we can do genre. And let's stay with the mean function for now. And let's try it out. So what I'm getting here is, you can see the index is the unique values in the popularity column, and the unique values from the genre column turns into the columns up here. And the values are the average Japanese sales across these categories, right? So action game sales in the lower tier category in Japan, for example. The above average category for racing games in Japan is here. All right, so let's copy paste this. Let's change it to European sales instead. And then also let's talk about the sum here. It could be quite interesting. And then we're gonna add in some more stuff here. More stuff. Or first I'm just gonna run it. I also want to change maybe this to platform actually. Okay. Good. Yes, okay, good. So now we can see if I'm doing platform, we get some NANs, so missing values here, which means that we do not have any puzzle games for this platform. Okay, so the sales here were 0. If I don't want these NAN numbers, which you don't, then you can say fill value and then specify what you want to fill the value with. So I'm going to fill the value with 0. Now, voila, all the NANs are gone. We can also do this. We can say margin equals true. If I do that, I'm going to get an additional column here and an additional row here. So what it does here is that it sums these numbers here. Boom. And on the row here, basically what we're doing is that we're summing this column up here. So we're creating sums on the two axes of this data frame. I can also change the name of these columns, so in the rows. So margins equals to, and then I specify the name, so total sum. Margins underscore name is what I should say. So total sum, or sum of sales might be better. All right, so that's basically the pivot table. So it's a double group by, right? And with unstack. So thing is, right, so I would say df.groupby. So what I'm grouping by is the index and columns. So platform, platform, genre, and then I'm selecting the values here, which is EU sales, right? Boom. And then the aggregation function goes here, right? Sum, boom. So now we have a double group by here. Then we also need to unstack, which is going to take the inner column here, turn it into columns, boom. And then we have the same thing. And then we will also, since it's not, have to use the fill a name method here, stack on top to get that thing. And then if we would sum, that would also be some extra steps, which is not relevant. So I'll just leave that for now. But the main point here is basically that the double group by and unstack is equivalent to a pivot table. All right, another really nice function that I also like to use is called the crosstab. The crosstab is quite straightforward. It has some other complementary, it's basically also a pivot table, but it has some really nice features that the pivot table method is missing. So if I say, I can just say this, crosstab is what it's called, like this, boom. So now I'm getting the number of action games from the 80s, number of fighting games created within this decade. All right, so that's just what you get if you just pass two columns to it. You'll get the count as values. We can build on to this. So this is basically the index, right? So I don't have to specify it, but it's good. And this is columns. I can also specify values. So the three first arguments I can pass here are the same as in the pivot table method. So let's look at EU sales again, capital S. And then I can select an aggregation function. Let's do sum, agfunc, is what it should say. Boom. So here we get the sum of sales for role-playing games in this decade, right? And if we would write this with a group by statement, I'm just group by, boom, would do decade, genre, EU, sales, dot sum, and then unstack, and that would be it. Boom. So this is giving us the same thing. So I just want to stress, because I think it's so important that you understand the group by. Double group by with unstack is the same thing as the crosstab and the pivot table. So the thing that's really nice here with the crosstab, I'm just going to copy paste this here this below, is that we can pass normalize equals true. Boom. Okay. If I pass normalize true here, I'm going to get the relative frequency. So here we can see that 5% of the sales comes from shooter games released between 2000 and 2009. 5% of the total sales in this dataset is equal to this value, right? All right, now I am going to take this column or this data frame, and I'm gonna call it genre sales. And I am going to show you as the last step here how to reverse a pivoted table. So if we want to unpivot something, we would use the melt method. Okay, so if we want to reverse this, we're gonna say just need to make sure I know. All right, so I'm gonna say id vars is gonna be equal to decade. Just need to say decade like this, decade. Good. Then what I want to do is that I want to say value vars, and this should be set equal to basically this list here, which are the columns, right, that I have. And then I need to come up with a variable name here. So that would be a genre, perhaps. If I run this, I get an error. Oh, I know why. I would have to reset the index here first. Then I get what I want. Alright, okay, so that's how you would have to return or turn a pivoted table and unpivot the table. Okay, now we're gonna move on to the second to last concept that we're gonna talk about, and that is concatenating data frames. So, concatenating data frames with pd.concat. Boom. All right. Okay, good stuff. So if you know how to concatenate strings in Python, boom, we're concatenating them, so adding the strings together basically. If you understand this concept, concatenating data frames is going to be really simple or easy for you to understand. So I'm gonna read into data frames here with long links, and can get them in the description below. So here what we have is two CSV files with the popularity of names for men and women in the 1960s. So the data looks like this. So we have the name and then how many were given that name within that decade. So men looks like this and women looks like this. Okay, now for some reason I want to concatenate them together because I want to look at the most popular name regardless of whether it's a female name or a male name. So I'm gonna concatenate these two together. So I would do that by typing concat, and then I would say objects equal to a list of these data frames. So men 60 and women 60. And then if I run that, we can see that the index is a little bit messed up. So I get the index here from 0 to 9, and then when we take the new data frame, it starts from 0 to 9 again. And maybe we don't want that. Maybe we want a range index that goes from 0 to 20 or 19 or whatever, or 18. Ignore index. Okay, so if I say ignore index equals true, we can see that it doesn't start at 0 here, it just continues from 10 to 18 to 19. Okay. Another thing that I could do if I don't want to ignore the index is that I could say keys is equal to, and then I specify a list here when I say men 60s and women 60s. So now what this gives me is an outer index here. So now it's quite clear why we're starting on 0 here, because we're moving to a different category. Most popular names amongst the men, most popular names amongst the women. I can also say pd.concat, and I say men in their 60s, women 60, and then I can specify axis equals 1. So then I'm concatenating them next to each other. This is not that common, but in some cases you might want to do that, so I'm just showing you. For this data, it makes more sense to do it on axis equals 0. I don't have to specify axis equals 0 here because it's the default, but I can do, and it's not going to change anything. So axis is how we want to concatenate them, on top of each other or next to each other. All right, okay, so another thing that would be a good use case for concatenation is to concatenate several files in a loop. So that's quite a common use case if you're a data analyst, that you maybe get sales data across different months, and each month is a separate file, and you want to loop over these files and concatenate them all together so you can perform analysis of the sales for the whole year. So to illustrate this, we're going to look at a bunch of different files. So I'm going to get all of these files by creating a list comprehension for links. So I'm gonna take this one here and I'm gonna put it here as an f string, and then I'm going to change men here. I'm going to change these 4 digits. I'm going to put them in curly brackets. I'm going to say I here, and then I'm going to do my list comprehension, which is going to be I for I in range 1920 2021 with a step of 10. Okay, so if I look at this, I get links to all the CSV files that I have for popular names across decades in Sweden. And what I can do now, so this is basically a list of CSV files. So what I want to do is that I want to turn them into a list of, I could also do the same thing for women, maybe, by simply saying we women and then here women. Okay, so 20 CSV files in a list. I want to turn them into data frames. Okay, so I would first, this is the easy way to do it, the simple way, so, or the newbie way. So you could do it with a loop saying for file in men, so looping over each link here. Then I would say df is equal to pd.read csv, and then here we would say file, the iterable, and then men dfs append df, and then men dfs. Boom. So now I'm getting a list of data frames. So I have a list of data frames, and the only thing I need to do now to concatenate them is to say pd.concat mens dfs, men dfs. Boom. And another thing that could be nice to do here would be to pass this to the keys. So if I would pass this to keys, okay, I don't know why it does that. List range so now I get a nice little outer index here for each decade. Right, and the more Pythonic way to solve this would be to solve it inside of a list comprehension. So if you would do it in a list comprehension, it would look like this instead. So I'll say, or maybe I'll do it with the women here. So Swedish women, pd.concat, and inside of here I'm going to create a list comprehension where I am reading all the CSV files. So file for file in women, and then I would also go out of this list comprehension here and say that keys is equal to the list range of 1920 2021 and then 10. So if I were to, now I have to find out the most common name across the decades in Sweden for women. GroupBy, it should say. So I want to group by name and select the column count. Oh my god. Count, and what is it that I want to do? I want to sum the count and sort the values descendingly. Ascending equals false. And the most popular name in Sweden last 100 years is Eva, and then is Anna and Kerstin, and then it's Karin. Anna is the name of my mother, and my grandmother's name is Karin. So popular names. Alright, okay, moving on here to joining. Moving on to the next one. This is the last thing that we're going to power through together today, and we're going to stay for this. This is really important. So we're going to join data with a method called merge. And if you have experience using SQL, you know about joins most probably and hopefully. So In Pandas, we don't call it joins, we call it merge. There is actually a function called join, which is absolutely horrible, and I'm not going to show it to you, but if you want to look it up on the internet, you can do that. Merge is a much richer method, so that's the one you should learn first at least. Alright, I'm pasting in 2 DataFrames here. You can find them in the description, the links are in the description. So now we're taking boys' names from the year 2019. We have an additional column, we have top 100 names, we have the count. So 620 people were given the name Adam in 2019, and the ranking was 9. And the boys 2020 looks quite similar. Alright. So to join data in Pandas, we use the merge method. And to explain joins, you normally show Venn diagrams. So Venn diagrams come from set theory. Venn diagram. And you've probably seen a bunch of diagrams if you've been on internet looking for memes. So this is a funny meme if you're Swedish on how we celebrate our holidays here. So this is the midsummer tradition and the Christmas tradition and the Easter tradition. And this little area where midsummer and Christmas is overlapping, we can see what midsummer and Christmas has in common. And what they have in common is that we dance around something green. And what the Christmas and Easter has in common is that it has something to do with Jesus. And in Midsummer and Easter we discuss if we should sit inside or outside because it's terribly cold in this country of Sweden. And when they're all overlapping is when we eat our beloved fermented herring. And so yeah, if you're Swedish, this is very fun. If you're not Swedish, it's not fun, probably, but it's not my problem. Okay, so you can also look at the different types of Venn diagram SQL. So this is a classic picture. Whatever. Okay, so here what we can see is that we have a bunch of different types of joins. We have an inner join, we have a left join, we have an outer join, and we have a right join. Now I'm going to explain them to you. So we're going to start off with the outer join. Also here going to change the output settings, so pd options dot display dot max rows equal to 500. Okay, just gonna run that, and then I'm going to say, so this is a syntax. Now I want to merge these 2 data frames, so boys 19 dot merge with the boys 20. Okay, and then I have to specify how do I want to do this join. Well, I want it to be an outer join, so I put outer in how. Then in order to join 2 data frames, we need to find a column to join on. So if I want to join these 2 columns, they need to have values that are in common. So what they have in common here is the name column. That's the column that I want to join on. So if there is Adam in boys 19 and in here, these rows are going to be joined together. Okay, so let me show you what I mean by this. So on the name column, then I'm also going to add, well, I'm just going to do it like this now. Boom. All right. So now for Adam here, or Adam, I get from the boys 19, I get these values, and from the other column, I get these values. And now it gives me a suffix of x and y. I can change the suffix by saying suffixes is equal to, and then I'm going to pass a list, and then I can say 2019 and then underscore 2020. So now I'm attributing some meaning to these columns. So we could see that in 2019 these many people got the name Adam. These many people got the name Adam in 2020, and this were the ranks of Adam was quite the same. And as we can see here, in this case, Albin does not exist in 2020's dataset, and that's why he gets not a number here. Alexander was number 12, 500 people getting that name in 2019, but he was not on the 100 list in 2020. And if we scroll down a little bit, I think we can see some other names here. So Loki, the trickster god in Norse mythology. He was not in the 2019, but he managed to get in there in 2020. Okay, so if we go back here to this picture, the outer join is, so if we're in this area in the middle, that means that we have no missing values. So they exist both in 2019 and 2020. If we have a look at the NANs here, we can see that since it was NANs, it means that they were not in both of the data frames. It was only in this one. And for the Loki, it was in 2020, but not in both of them and not in here. And I guess the best way to explain this would also be to say indicator equals true. So if I say indicator equals true, I get a new column here. So we can see that Adam exists in both tables. Albin only exists in the 2019 table. And then scrolling down here to my name. I was only in 2020 data frame, but not in the 2019 one. Alright, so moving on to the inner join. I'm just going to copy paste this, put it here below. So if I'm doing the inner join here, I'm not going to run it yet. I'm just going to go back here to this one. So this is the inner join. Inner join is only going to include matches that exists in both tables. So for example, Axel only exists in 2020, it will be excluded here. So if I run it, they have to exist in both tables. So we can see that here, we can validate it with the indicator parameters. We can see it should only have both here. Both. Okay, so that's the inner join. We can turn it into a right join by typing right. So if I'm doing a right join, I'm gonna get everything that exists only in 2019 and the ones that exists in both tables. So we're gonna get both and right only results here. Nothing should say left only. It should be both and right only. So that's the right join. Then we have the left join. Boom. It's the same thing as the right join but reversed. So we have both and then left only and both. That's the only thing we get here. Okay, and then moving on, what I could do is to copy paste this and say outer join, and I'm gonna save it to boys 1920. Okay, so here I can select the merge column and do value counts. Oops, value counts like this, and now we can see that, okay, 62 names exists in both 2019 and 2020. 39 names are only in the 2019 table and 38 names are only in the 2020 table. So by using these values inside of the lock statement, so we could do boys 1920. By using both of these inside of the lock statement, I can get these joins. So the join, I can get the left join. This is a left join. I said it was a right join before, I apologize for that. So I can get a left join without intersection. Okay, so I'm getting the values that only exist in the left table, and I can also do that with all the tables exist in the right table. And I can quite easily do that by saying .lock so this would be a left join without intersection, right? And I can do a right join without intersection. And using all of these three in various combination, I can also obviously create any type of join. So if I wanted to create a left join, I would do .isin, pass a list here, and then I would say both and change this to left. So now I get a left join. All right, and that's basically it for the merge method. One thing to say about the merge method could also be that if we want to join on the index column in some cases, we're going to have to specify that on the right index or left index and set it to true. If the column names are different but you can still join on them, we're gonna have to use left on and right on. But that's basically it for this. That is it for this Codealong. If you made it to the end of this video, congratulations for dedicating yourself to learn Pandas. It's a solid investment of your time. I really hope you enjoyed this video. I did for sure enjoy making it. If you're interested in learning more, I think you should subscribe to this channel because I'm going to post more lessons shortly. And if you have any question, comments or insults, put them in the description.